Okay, now we've got some new sets A, B, and U. Now this picture doesn't correspond to these sets at all. We've got a completely different collection of 3 sets. Okay, but generally, if we have 3 sets, we can draw a Venn diagram representing those. Well, I'm sorry. We have a universal set and 2 sets within that universal set. Okay, so if this is our universal set, this is set A, this is set B, then this represents the general case where A and B have some intersection and they're both within the universal set, but there's stuff outside of the 2 sets that's also in the universal set. Now let's say that the number in the universal set is 35, number in A is 20, the number in B is 25. Now I've done that here, but let me write it over here just so you see how it develops. Okay, there are 35 in the universal set. There are 20 in the set A. Now put that 20 so that it's kind of intersected by the boundary of the set A. So we know that the 20 stands for everything in set A. In set B, we're going to put 25, and notating it similarly. Also, the number in the complement of A union B is 6. Now, what's the complement of A union B? What's A union B prime? Well, A union B consists of everything in A as well as everything in B, and everything outside of that is the complement of A union B. So that's everything outside here. So we can say that the number in A union B prime is 6, meaning that there are 6 objects in the universal set that aren't within the circle for A or the circle for B. Okay, now what does that lead us? How do we account for all the members of the set? Well, if there are 6 members outside of A union B, that is 6 members in the complement of A union B, and 35 members in the set U, that leaves 29 members for the set A union B. So I've written that out down here, but this is kind of symbolic, might be a little harder to understand than the picture. Just saying, number in A union B plus the number in A union B prime has to be 35, because within the universe, everything outside of A union B added to everything inside of A union B is everything. So that these 2 numbers have to add up to 35. It follows then that the number in A union B has to be 35 minus the number in A union B prime, which is 35 minus 6, or 29. In terms of the picture, you've got 6 here, and everywhere else consists of just whatever's inside of these 2 circles, either or both, and that's 29. So you have 29 elements in A union B, 29 elements dispersed within these sets. Well, if we add the 20 in A to the 25 in B, we get 45, not 29. Okay, so what's our conclusion? Well, let's just write what we've got. Number in A is plus a number in B is 45, but the number in A union B is only 29. How can that be? How can A have 20, B have 25, but A union B has only 29? Well, the only way that can happen is if there are a bunch of them in this intersection, because when you add the number in A to the number in B, whatever's in the intersection is getting added twice. Well, if you think about it for a minute, that means that the difference here between 45 and 29 or between 29 and 45. The difference is 16. And that 16 has to be in A intersection B. So we know we've got 16 here. Now, if we have 16 here, how many do we have here? Well, there are 20 in the circle. 16 of them are in this intersection. That leaves us only 4 out here. So how many are in this part of B? 16 in the intersection, 25 in B. That leaves 9. Now notice that those numbers are written inside of the regions, not on the boundaries of the regions. Okay? So they indicate the numbers in the smaller regions here. So we have 4, 16, 9, and 6. And of course, if we add those up, we get 35. We get all 35 members of the universal set, and we've accounted for all 35 members of the universal set. So our conclusion, and I didn't get to write this down in class because time kind of took us, and we just filled in this picture here, but the number in A intersection B has to be what? It has to be the number in A union B and I wrote that down before I engaged my brain. It's the number in A plus the number in B minus the number in A intersection B, A union B. Again, the difference between 20 plus 25 and the 29 that we know we have in the two sets. Okay? The number in A minus B, well, A minus B consists of everything in A that isn't in B. Okay, the things that are in A that are in B are in the intersection. So that the number of elements in A minus B has to be the number of elements in A, not minus the number of elements in B, but the number of elements in A intersection B, because you don't take them out of A unless they're in A. You can't take something out that's not in the set. So it can't be number A minus number in B. In this case, that would be really bad because you got more in B than you have in A. It's a number in A minus a number in A intersection B, which is then 20 minus 16, or 4. Of course, that confirms what we have up here. And of course then the number in B minus A, or the cardinality of B minus A, is cardinality of B minus the cardinality of A intersection B, which is 25 minus 16, or 9. Now you see a number of examples where you get to work this sort of thing out. It's kind of a puzzle, kind of a number puzzle. And it takes a little practice, but once you get the idea, it's actually kind of fun, and it just takes a little while to get used to. Now, as I said in class, there are situations where you have 3 sets, a set C. And then instead of having 1, 2, 3, 4 regions, in other words, instead of the 2 sets breaking the universal set up into 4 smaller regions, the 3 sets are going to break the universal set up into 8 regions, and things get a little more complicated, and you got to keep your wits about you. And I did say in class that if you don't get those problems that involve the cardinalities of the different regions, when you have 3 sets, get used to doing it with 2 sets, and I'll give you 1 extra day, which actually turns out to be an extra 5 days to get that in. So you want to turn in everything that's been assigned now in the sections that have been assigned, but you can leave that much of this section 4 off of the homework if you can't get it done. I encourage you to get it done if you can.